Hello friends, this is Yusuf here. Welcome to part 14 of our crash course RPGLE. So in this video, we're going to pretty much see about how do we work with DB2 file from RPGLE. So it is an important video because we'll be using a lot of file operations in RPGLE when it comes to the application development, right? So I don't know whether it's going to be a single video or a multiple video because we need to cover a lot of stuff, and I'm going to be explaining from very basics because I wanted to make sure that we understood each and every concept correctly. Okay, so on an overview, right? So if you want to deal with files from any programming languages, right, so what we need a CRUD operation: create, read, update and delete, right? So for that, db2 offers an inbuilt opcodes. So these are all the opcodes to work with files, especially physical file. Okay, so read previous, set else, set gt. So there are a lot of steps. Maybe we'll see one by one with the example. Further, what I have done, I have created one file. Okay, we'll show the file first. So this is a student PF I created, which is having three fields: ID, name and department, and we have defined the student ID as key. Okay, and then I also have one LF. Okay, here you can see I don't have anything else here, which means all the three fields will be taken for this LF, but the key is based on department. Okay, as far as the data is concerned, so I have loaded with some data. So studpf. Okay, so these are all the 6 records I have. We're going to deal with these 6 records and then see how to do these operations. Okay, for simplicity, I also have this record in Excel just for explaining stuff. So let's get started. Yeah, first I'm going to take F6. Okay, and then I'm going to say stud01 or rpgle. So it's going to be an rpgle program, and till now we have seen many specification. Now we're going to see F specification. Take F4. So F specification is for declaring a file. So now we're going to declare a file student pf. Okay, and then here I have to give I and then F. Okay, so I denotes it's a input mode. So we're gonna open the file in input mode, which means we cannot do any update and delete or create. We can only read. Okay, F stands for fully procedure file. Okay, so we don't need to care about this end of file, but file addition, if at all we are going to add the record, we'll give A. So as of now it can be blank, and file format is E means externally described file format. So that's it. And then record address type. Okay, how do we going to address the record? So here you can give K. If your file is having any key, based on the key we can retrieve the record. So we'll see that in action. So we can give K there, and then in device give disk. So this is actually a pretty much a basic declaration. So if at all we want to have this file for update or delete or add the record, right, we just need to add few more parameters. So as of now you can think ifek disk. Okay, fine. So what I'm going to do, nothing, just going to say free and free, and inside I can say star inlr equal to star on. Okay, we're going to start writing the code. So what is the first thing we are going to see? So read is actually the opcode, basic opcode to read the record. Okay, so I can say read and then file name is studpf. Okay, and once I read the record, what will happen, right? First of all, when we declare the file itself, all the fields of that file will be available in this program as a variables, so we can directly use it. Okay, which means now after I read the record, I have access to the variables or the column names of that particular pf, and I can directly use it, which means I can display something like s name. So s name is one of our variable, right? So this will read the record and display the name. So first of all, I'm going to compile this, and stud01r, so 14. Okay, before I run the program, right, work job 4. So this is a spool file. If you come down, right, here we declare the file student pf. So here you can see when we compile the program from where the physical file is referring. So you can see that, okay, it's referring from this file, and it is a record format. And if you come down, right, you can see these 3 line is added by the compiler, which means now these variables are accessible from the program. Okay, so that's why even though we didn't declare a sname variable, but it is coming from the pf. So you can see the sname here. Fine. So what we are going to do, call stud01r. So it just displayed the name Yusuf because that is our first record. Okay, you can see. Suppose if you want to see the next record, the pretty basic thing is actually to read the file again and display it. Okay, and then this eventually what's doing, it is reading the file 2 times, and when we read the second time, it gives the second record. You can see you got the, sorry, we got 2 records. So now I want to explain a thing about pointer. Okay, so the file read is based on the pointer. So initially when we declare the file, the pointer will be nowhere, and when you read the file for the first time, the pointer will come and sit in the first position. Okay, and then for every read the pointer will increase. Okay, go on. So for example, if I say read p, right, so read p stands for read previous. Okay, so here I can say instead of read, I'm saying read p. So now you can imagine the pointer is at this second portion. When you say read p, it will read the previous record, then it will read the first record again. So let's see if that works. Okay, so I'm just displaying the name again, file, compile, run. Okay, so you can see, right, the first record, second record, and then read previous will read the previous record, which is the first record. So read and read p will work based on the pointer. Now say for example, I want to directly read this particular record. Okay, so how do we do that? So for that we have this opcode called read e, so which is stands for read equivalent. But for reading a value equivalent, we need to give the equivalent value, or we need to give the key using which the program can read the record. Okay, in our case we need to give some attribute of this record so that the program understand this is the record we are looking for. So for that normally we will use key. Okay, as I explained earlier, this file is created with the key as SID, which means if I pass the SID value 5, then I can get the record. So let's see if I can get that. But the thing is, if you want to use the read, right, first we need to set the pointer to that location first, then only we can do the read. What I'm telling as a pointer is actually currently, if you see, we saw the pointers here, then read p, again it went to the first position. But if you want to read this record, right, we need to use read e, but for read e we need to first set the pointer to that particular location. So that we can do that using setll, okay, which stands for set lower limit. So I'm going to have setll. Okay, it takes a key. Okay, I'll tell what is this key is all about, and then std. So what is this key? So generally this key stands for the particular key of that particular file. In our case we have only one column as a key. So what I can immediately do, wait, it takes 2 time. Okay, so here I can just declare this key as a standalone variable, but I don't give the declaration, I give like SID. Okay, because we know SID is the key of this particular PF. Okay, I'm declaring a variable called key and then giving it with the declaration of like SID. Now what I can do, before I do setll, I can define the key is equal to 5. Okay, basically key is actually now a variable, it holds the value 5, and with that key I am doing the setll. Then if I do read e, the read e takes also the key. Okay, and then std_pf. So I'm telling the program to read equivalent record which is based on this key. Okay, and then just display s name. Now let's see what happens. So file, then f10 call stud01r. Okay, so now you can see we got first record, second record, and then we are using read p, so it reads the first record again. But all of the sudden we are getting this record afterint because we are using setll read. Okay, fine. Now now let's take another opcode which is nothing but set gt. Okay, so likewise setll, right, setll stands for set lower limit. What I mean is lower limit, actually when we set the setll with key as 5, it actually stands or points the cursor in between 4 and 5. So that's why when you do the next read e, it reads the 5th record. Say for example I am doing a set gt, then the cursor will be pointing after the record 5. So in that time if I use the read e, I will not get the value because there is no equivalent value record with the SID as 5 available. Okay, so set gt, then I have to use the read PE because read previous only will match the record. let me show in action. Okay, so now we understand this point, right? So if I use set gt, I'm doing a set gt with the same key, then the cursor will point after this fifth record. So I cannot use the read e because there is no 5 after that, so I have to use read pe. So here you can see, instead of read e, I can say read pe, so read previous of equivalent. Okay, now this should also give us the same result. Let's try. Okay, so you can see we got the same result. Fine. Now let's go and see some other different example. See, here I have some examples. So read the whole file. Now let's try to read the whole file. Okay, because we don't want to keep on giving read, right? So we're going to read the whole file. For that, what we're going to do, so how do we know that the file is actually read? Okay, we have something called EOF indicator. Okay, something like this EOF. Okay, this particular indicator will be switched on if we reach the end of the file. So we're gonna see with that actually an example. I can do something like this. So assume I'm deleting all the record. Okay, fine. So it's going to be experimental. Okay, so let's see what happens. So for I is equal to 1 to 10. Okay, n for, so this for will run for 10 times. I'm just going to say read std_pf. Okay, and then I'm going to display the s name. Okay, and then I'm going to delete this also, this also. So you see what I'm going to do, right? Actually, I'm just going to experiment. If I just read many times, right, what's going to happen basically. Okay, let's give a file, and then okay, we didn't declare the I. Let's see, we can declare here. Come on, I. So I can tell this I is actually s of type maybe 2s0. Okay, so I'm just experimenting it so that we understand the concept correctly. Compile it, call. Okay, great. So what we see is for each read, right, it actually read the next record. Okay, 1 2 3 4 5 6 until the sixth record we got everything paka. But after the sixth record, right, we keep getting the last record. Okay, but it doesn't mean that it is reading the last record again and again. Okay, so for this only I'm gonna give another thing. So how do we know that we reached the end of the record? So here I'm going to show that. Okay, I'm going to say this UIF, and I'm going to declare this as type n. So if you remember during our earlier videos, n means it's an indicator. It takes either 1 or 0, true or false. Okay, and when we read the value, right, I'm going to say EOF is equal to percentage EOF of student PF. Okay, I'm checking the EOF indicator. Okay, and then I am displaying the EOF. So I can display character of EOF. Okay, now let's see what happens. It takes time. Okay, yeah, file, great. So now if you look clearly, right, until this is fifth record, okay, sixth record. So until the last record, the EOF indicator is actually off. But after the sixth record, when you do the read, right, the EOF indicator becomes 1. Okay, so this is the indicator which we can use to identify whether we reached the bottom of the record or not. Okay, so now I can change the program. I just wanted to explain this stuff, so only I put the for loop and all. Now we can do something like do while, okay, not percentage EOF of std_pf. Okay, which means actually I need to read this first. Okay, I need to read first, and after reading, suppose say for example it is the first record. Okay, and I'm checking the EOF indicator. If it is not a EOF indicator, which means it is a 0, okay, then I can just display this particular name, and then I can read it again. This I don't want, this I don't want, and then this I can change it to n do. So now you understand the concept, right? So first we are reading it, and then if suppose we didn't reach the end of the file, then we are displaying that particular value which we have read here, and then we are reading the next record, and it goes the loop on and on. So if we do this, it should read all the records. So let's try stud01 okay. So now we see we just read all the records and it came out of the loop because the UEF indicator becomes 1. Fine. So we saw this example which is reading the whole file, and now let's see read the particular record. Okay. What I mean by that is, okay, for example, what if I wanted to read only the records which is having the department IT. Okay, now let's think. If you want to read only a record with IT, I need to somehow tell the system or program that I'm looking for this, right? For that I need a key with this particular column, but we don't have this column as a key. We have only this column as a key. So here only the logical file comes into picture. Okay, so if you see this logical file, I have with the same PF, but just I'm changing the key to the department. Okay, and here I will show another interesting thing. Okay, so we just see this, right? Assume if I change this PF to LF1. Okay, I'm not doing anything, I'm just changing to LF1, and here instead of reading PF, I'm reading LF1. I'm checking whether LF1 end of file or not, and then here also after displaying the name, I'm reading the LF1 again. Okay, we just changed the PF into LF, and let's see what is the output, because I'm going to show you something. 14 call stud01. Okay, now see the order is different. Okay, that is because the LF is actually having the key as department number. Okay, so when we read the file, right, the program automatically reads the record in its order of the key. So if you see in this thing, right, if I just select this and then what is that, custom sort by, oh come on man, I don't know, this is Mac. Sorry, I don't know this how to use. Anyway, so if you sort this by department, right, we'll get CSE first and then EC, then IT. That's why Yusuf is first record, and then Haja is second record, and then remaining IT become third record. You see Yusuf, Haja, then Sachin, Abdul, Jagir, so on. So because it reads in this particular key order, that's what I'm trying to highlight here. Okay, fine. Let's go back, and then now what we're gonna do, I'm going to use the same file, because this file is having the key as department. I want to read only the IT. Okay, so what I need to do, I have the key, and then I'm going to say this key is similar to SDEPT. Okay, and then I need to say here this this key is equal to IT. Sorry. Okay, I need to indent this. Okay, so this key is equal to IT. Then what we need to do? We need to do set LL with this key on STUDLF1. Okay, fine. After that, I'm going to issue a read E with the same key on STUDLF1. So this combination of these two lines will try to read the first matching record of that key. Okay, and then I don't want this line now. Okay. So with this combination, when I read the first record, if suppose it is found, then my end of file indicator will be 0. So I can come in and then I can display that particular name, and then what I need to do, I need to read the same equivalent record. Okay. Okay, see, if I just use read, then it is going to read the next record, that's it. But I want to read the next record but equivalent to that key, so I need to use read E. Okay, and then let's see, it goes back again, then displaying the name, the same stuff. Now let's see whether it's working or not. So we have key here, everything okay, fine. So file, come on, file, call 1 2 3. So it displayed only 3 records. Okay, here you can see Abdul, Zahir and Afrin. That is because only those are actually the IT fields. Okay, I hope it makes sense. Okay, now you understand the meaning of settle and read. So read is going to read the equivalent record what you are going to specify. Okay, so okay, now let's quickly tell me about read PE also. Okay, say for example, we just, what if you want to read in reverse order. Okay, let's see the same 3 records, but I want to read in reverse order. Okay, so what I need to do, simple, I'm having the key, but I need to do set GT, so it will set the pointer to the greater limit. Okay, and then instead of read E, I need to say read PE, and if that is having any record, then I'm just checking the end of file, and then I'm displaying the name, and then here I should say read PE. That's it. File 14, compile, F10. So we got initially this order. Now we should see in the reverse order. Okay, let's see we are getting it or not. Okay, see new Afrin, Zahir and Abdul. So before what we got, Abdul, Zahir and Afrin. So it is reversed. Okay, so this is the usefulness of setgt. Okay, I think it's already 20 minutes. So I don't want to continue from here because I don't want to make a longer video. I'll finish this with the chain operation, okay? Because these all opcodes are related to read operation. Update, delete and write, maybe I'll show it in the next video. Okay, let's quickly see the chain. Chain is actually a most used opcode, okay? So chain is actually a combination of setll and read. Okay, now here see, let's do the same stuff. So here previously we had settle, right? Okay, let me go with the example. Okay, I want to see this only this record. Okay, I want to see the fourth record. I want to key with this ECE. Okay, so what I'll say ECE. So this is my key, and then here I'll do set LL and then read E. I don't want this. Okay, and then I'm going to display it. I don't want this. I don't want this. So we all know this will read me only the first one record. Okay, but here I can combine these two statements into a single statement. Okay, that is called chain. Okay, I'm going to chain with this key and then onto the file stud lf1. Okay, and then display. So now let me comment this one. This should also work. Let's see. Okay, call. So we got the one record. Now what if I give something which is not available? Okay, we're trying to change the value but it's not available. Let's try that out. Okay, let's try with the examples and then learn. Call. So it displays blank because it is checking for the value but it is not getting any record, so it is giving you the blank details. So how do we capture this particular thing? So when you do a chain, right, we have an inbuilt method called found. So that will be, okay, see if percentage found of student lf1, this indicator will be switched on, switched off based on that. Okay, else and if. Okay, so here I can say move this to found, then a. Okay, come on. Okay, else I want to say display not found. Let's try this one. Call. See, we got not found. Okay, if at all we match the record, say for example I give CSC, because we have record with CSC, file 14, call, we got Yusuf. So that's it for this video. I'm just covered all the opcodes which is needed for reading the PF in whatever the way. Okay, maybe in the next video I'll be explaining this update, delete and write, because we don't have different opcodes for update, delete and write. Okay, we have only one opcode. Only for reading the files we have this much option, so I wanted to cover in detail for all the level of people. Hope this makes sense. So that's it for this video. I'll see you in the next video with the next concept. Thanks for watching.